Conflicts break out one after another in different parts of the planet, but to get peace on Earth, you need to guarantee security in the sky. This rule is understood by the Japanese engineers of Mitsubishi better than anyone else, having been tasked with developing and rolling out their own 6th generation fighter. And that's what we'll be talking about in today's video. Like the United States, Japan is well aware of the scale of the threat posed by the regular military buildup of its friendly neighbor China. In particular, the increase in the Chinese military aircraft fleet, which currently numbers about 2,566 combat units. At the beginning of the 21st century, Japan sought to replace its aging fleet of fighter aircraft by attempting to acquire the Lockheed Martin F-22 Raptor from the United States. However, due to the federal ban on the export of these unique reptiles, the states were forced to refuse their allies. As a result, Japan decided to focus on developing its own modern fighter aircraft equipped with stealth and other advanced systems. Still, you can't achieve effective stealth in a swoop. After all, many of its variables require years of complex engineering development and a proven combination of technologies. Take the following: radio-absorbing materials, thermal management systems, seamless and mixed wing configurations with a lower likelihood of generating a reverse signature, as well as specific recessed engine designs. But this country was confidently moving toward its goal because, in addition to boosting its own industry, such a move meant that in the future it would have to rely less on foreign governments to obtain key military technologies. In addition, the development and creation of domestic stealth capabilities would help Japan improve its own radar systems, repelling two regional aggressors at once, China and Russia, which, at that time, were also in the process of creating their own stealth aircraft. Thus began the Advanced Technology Prototype X (ATD-X) project, which grew into the Japanese stealth prototype Mitsubishi X2 Shinshin, whose name means mind or spirit. Its development was entrusted to the local tech giant Mitsubishi Heavy Industries and the Japanese Ministry of Defense Technical Research and Development Institute, TRDI. In 2006, a 1/5 scale radio-controlled model of the X2 was tested to obtain high angle of attack performance data, test new sensor hardware, and self-correcting flight control systems. A year later, the project received funding with plans to start production in 2017. In 2014, TRDI showed the first photos of the prototype for the future fighter, stating that it was already undergoing ground tests, and its official presentation took place in the winter of 2016. Also in 2016, the X2 made its first flight from Nagoya Airfield, landing at JASDF Gifu Airfield. It was planned that the prototype would undergo 50 test flights, which would end in March of 2018. While development of the Shinshin was in full swing, the Japanese Ministry of Defense also proposed in 2010 its concept for a successor to the aging fleet of Mitsubishi F2 multi-role fighters called the I-3 fighter, where the I-3 stands for Informed, Intelligent, and Instantaneous. That same year, Japan Air Self-Defense Force, JASDF, published the report, A Vision for Research and Development of Future Fighter, once again emphasizing the importance of domestic development to maintain its own fighter production base. JASDF proposed to create an anti-stealth fighter capable of detecting enemy stealth aircraft with its combat information system composed of high-power radar, advanced sensor suites, and tactical link with external sensor nodes. Additionally, the Japanese aircraft would work in a group with UAVs, defeating enemy aircraft using network-based team tactics. They also wanted to equip the I-3 with advanced stealth capabilities, a fly-by-night flight control system, small but very powerful engines, an advanced set of sensors, a cloud shooting capability, network fire control, and even a directed energy weapon, which the Japanese Air Force called Light Speed Weapon. The ATD-X program with the X2 Shinshin prototype was expected to lead to the creation of a 6th-generation fighter, the Mitsubishi F-3, which was planned to be produced before 2027. And so it happened. In April of 2020, the Japanese Ministry of Defense officially launched the FX program. In accordance with the Midterm Defense Program, it was going to be implemented in 15 years, just in time for the F-2 to begin retiring. The ministry highlighted 5 key aspects of the program: future air superiority capability, potential for empowerment through next-generation technologies, ability to modify and upgrade a new platform, Japanese industry participation, affordable price. Well, the requirements are good, but what will the new Japanese fighter look like exactly? Of course, the final result may turn out to be completely different. However, this doesn't cancel the public's interest in Godzilla. Yes, this is exactly the nickname awarded to the Japanese aircraft by Bradley Perrett, Asia-Pacific Bureau Chief from Aviation Week. The reason was the dimensions of the device, exceeding even the American F-22. By the way, the impressive size clearly indicated the greater flight range and carrying capacity of the FX fighter. This assumption was also reinforced by Japanese Defense Minister Taro Kono, who stated that the FX will not only have strong network capabilities, but will also be able to carry more missiles than the F-35 Lightning II. During the design process of the FX twin-engine stealth fighter, engineers came up with many concepts that were then put through a 3D digital mock-up system. Data about the vehicle's avionics, its stealth, and engine characteristics were all entered into the simulator, and then were checked by JASDF pilots. Thus, using air-to-air combat simulation, the Japanese evaluate the effectiveness of the current concept and improve the design of mock-ups. Unlike its predecessors, the FX replaces the use of traditional hydraulic systems with electric drives. This choice was made due to the complexity of designing the interior of a 6th-generation fighter. Japan's Ministry of Defense said that when designing the exterior and interior of a stealth aircraft, important design aspects include the internal weapons bay and air intakes. But if you install a hydraulic system, then problems arise due to design considerations, specifically rigidity and length. The use of electric drives eliminates these difficulties, since they're connected only through electrical wiring. This makes installation as simple and restrictive as possible, giving engineers greater flexibility when designing the fighter's airframe. Furthermore, this reduces the weight of the device and greatly affects its mobility, which is reminiscent of the current paradigm of American fighters, where speed is the new invisibility. With FX, the Japanese abandoned the use of fasteners, going the route of gluing composite materials through molded adhesive. This method is known as integrated/fastenerless structure, and heat shield technology was used around the engines, allowing the use of aluminum alloys and carbon fiber reinforced polymer (CFRP). All this greatly helped to lighten the design. The FX's predecessor, the Mitsubishi F-2, used integrated molding and CFRP, but this technology was only used on the lower wing plates, requiring fasteners to be installed through the upper main wing plates and other areas using fasteners on both plates. With FX, the use of carbon fiber and adhesive molding was extended to the entire fuselage, reducing the weight of the airframe by 11.6%, and reducing labor costs for the middle part of the fuselage by 66% compared to previous approaches. A small, specialized heat transfer system will help the 6th-generation Japanese fighter handle the heat generated by onboard systems. It's modeled on the vapor compression refrigeration cycle and assists the air cycle as well as the liquid cooling system. To minimize its radar cross-section, the FX design includes serpentine ducts containing electromagnetic wave absorbers, which has the effect of reducing detection range from radar threats by about half. They're also present in engines. These absorbers are built with carbon-based material. For additional ESR protection, the FX makes maximum use of passive detection to reduce the likelihood of counter-detection during radar emission and plasma stealth antenna technology to deflect radio waves. The FX stealth aircraft will be assisted in detecting enemy aircraft by its built-in advanced sensors. These include Active Electronically Scanned Array (AESA) radar, passive radio frequency (RF) sensor, and infrared camera. Moreover, both the AESA radar and the RF sensor use gallium nitride (GaN) to improve performance. According to Japanese engineers, the AESA radar in the FX is based on the J/APG-2 radar from the F-2 fighters, and is identical in its capabilities to the AN/APG-81 radar installed in the American F-35 Lightning II. And in order to effectively repel all incoming threats, the fighter's systems perform two important functions at once: electronic support measures, ESM, and electronic countermeasures, ECM, instantly warning the pilot about threats by interrupting their radio waves. The engines chosen were two XF9s, whose power contrasts greatly with their dimensions. For example, the air intake is 30% smaller than what was installed in the General Electric F-110 engine on the Mitsubishi F-2 fighters. The thin design of the XF9 plays into the hands of stealth, and allows the engines to be easily buried in the body of the new Japanese fighter. And the nozzles, with three-dimensional thrust vectoring, guarantee the aircraft amazing maneuverability. Although preliminary results of 16.5 tons of thrust are slightly lower than the Pratt & Whitney F-119 engines installed in the F-22 Raptor. In order to repel threats and destroy enemy targets, in addition to the radars, there are plans to also equip the FX with supersonic ASM-3 anti-ship missiles created by Mitsubishi Heavy Industries, and a microwave weapon to suppress missiles approaching the aircraft. At the same time, let's not forget about the active development of UAVs that will work in conjunction with FX called Combat Support Unmanned Aircraft. The program is similar to the Kratos XQ-58 Valkyrie and Boeing Air Power Teaming System projects, where drones act as the loyal wingmen of the aircraft controlling them. Having gathered enough information from flight tests of the X-2, Japan came to the conclusion that it would still need the help of international partners to create a new generation fighter. Many large companies responded to its call. The American Lockheed Martin proposed an updated version of the F-22 Raptor, but Congress still had the final say on its transfer. Boeing presented a model based on its F-15 Eagle. The British BAE Systems also entered into negotiations, intending to roll out an improved version of its Eurofighter Typhoon to the Japanese. And Northrop Grumman pulled out the prototype of the F-22 Raptor's progenitor, the YF-23, from a distant drawer, offering an improved version of it. Moreover, after carefully reviewing the designs, Japan said the F-15 and Eurofighter Typhoon did not meet Defense Ministry requirements. And Lockheed Martin's hybrid stealth fighter, a cross between the F-22 and F-35, was in doubt due to its high cost, with an estimated price of $177 million, as well as Tokyo's uncertainty that the United States will still approve the sale of the Raptor. In the summer of 2021, Japan announced negotiations with the British in cooperation with Rolls-Royce in engine development. As it turned out later, things weren't limited to. In December 2022, the authorities of Japan, Great Britain, and Italy made a joint announcement about the development and deployment of a common multi-role fighter. The countries decided to combine their previously separate projects into a single Global Combat Air Program, GCAP, whose ultimate goal is to lift the 6th-generation air platform into the sky by 2035. To date, the UK Ministry of Defense has already allocated about $2.5 billion for GCAP until 2025, but Italy and Japan also pledged to contribute, matching the British investment. I wonder if France, Germany, and Spain will join this group, working on a pan-European new generation fighter, the Future Combat Air System. What do you think about the new Japanese fighter and the fate of the industrial base of the Land of the Rising Sun? Let us know in the comments below. And if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.